Okay, let's talk about solving exponential equations where there is an equation in the exponent. When dealing with exponential equations and there's an equation in the exponent, first we need to find a common base and then simplify if needed. You're going to solve the equation then using opposite operations. So let's take a look here. 5 to the power of 3x equals 5 to the power of 3. These already have the exact same base, so I don't need to change anything. I can just jump straight to only looking at what is in the exponents. I can say 3x is equal to 3. Now we need to solve for x. In order to find x, I need to divide both sides by 3. I am given x equals 1. Let's look at this problem here. 2 to the power of 2x is equal to 16. I don't have a common base here, so I need to find it. 2 to the power of 2x. In order to get 16, I need to go 2 times 2 times 2 times 2 to give me 4. 2 to the power of 4. I can then only look at my exponents. I can jump to 2x is equal to 4, and then divide both sides by 2, giving me x is equal to 2. 3 to the power of negative 2x is equal to 81. Well, I personally don't know how many times 3 goes into 81, but we can figure it out. If you don't have your reference table, if your reference table doesn't go up this high, or if you just don't know, here's how to find it using a calculator. I'm going to go 81 divided by 3. That's once. Divided by 3 again. That's twice. Divided by 3 again. 3 times, and we need to do it one more time to get it down to 1. 4. I can double check 3 to the power of 4 equals to 81. So I can go ahead and rewrite my problem now. Three to the power of negative 2x is equal to 3 to the power of 4. I can jump to only looking at my exponents. It gives me negative 2x is equal to 4. I divide both sides by negative 2. 4 divided by negative 2 is negative 2. So my answer is x is equal to negative 2. Okay, 6 to the power of negative 3 minus 2 equals 36. Let's start off right off the bat by changing the 36 to have a base of 6. 36 is the same thing as 6 to the power of 2. Now that I have the same bases, I can only look at my exponents. So I can jump to negative 3x minus 2 is equal to 2. Now I just need to solve. I'm going to move my negative 2 to the other side, leaving me with negative 3x is equal to 2 plus 2, which is 4. I divide both sides by negative 3, and x is equal to negative 4 over 3 is my final answer. Okay? 4 to the power of x plus 1 equals 1. I need to find 1 such that it is a base of the number 4. Well, 4 to the power of 0 is 1. Now I can jump straight to my exponents. I can say, well, x plus 1 is equal to 4, and therefore x is equal to negative 1 once I move the 1 over. Now let's look at a problem where you have an x in both sides of your equation. Now fortunately here, they have the same base, so I don't need to change the bases at all. I can just jump to looking at the exponents. Negative 3x equals x minus 1. I'm going to rearrange. I'm going to pull my x over to the left-hand side here. So it becomes a negative x. I combine my like terms. And now I need to divide both sides by negative 4. That leaves you with x is equal to 1 over 4. And we can see in these two problems in D and in F, it's totally fine if you get a fraction. X does not always need to be a whole number. And let's deal with one last problem here. 7 to the power of 2x plus 4 equals 49 to the power of 2x. Well, I need to put 49 as 7 to the power of something. 49 is the same thing as 7 squared, and then we still have a 2x here to deal with. So I'm going to put that in brackets. Now that I have the exact same base, I can ignore my base. I can just jump straight to my exponents. 2x plus 4 is equal to 2 times 2x. Now we're just going to use our opposite operations, rearrange and solve. First, I'm going to use BEDMAS to get rid of my brackets. 2 times 2x is 4x. Then I rearrange, I pull my 4x over to the left-hand side. And I'm going to put my 4 to the right-hand side. 2x minus 4x is negative 2x. And then I divide both sides by negative 2. Negative 4 divided by negative 2 is 2. And that is my final answer.